used to illuminate two slits in YdsE experiment. Separate between the slits is small b and the distance is small d. Separation between slits small b. Distance between slit and screen d. Distance between slit and screen. And here D is less than B. D less than B. At point on the screen directly in front of the slits, certain wavelengths are missing. This is the concept of missing wavelength. Very, very important concept. Missing wavelength. We need to calculate in front of the screen. So actually, this is one slit. This is another slit. This is at the point P on the screen. This is a point P on the screen. So this is S1 slit, this is S2 slit. So distance between two slits is B. This is small b. So this is the point P on the screen. General concept. But here, one of the slit is placed in front of the screen. One of the slit is placed in front of the screen. One of the slit is placed in front of the screen. One of the slit is placed in front of the screen. In front of the screen. One of the slit is placed in front of the screen means this is one slit. So this is another slit. So S1 and S2. These are point P. This is small p. This is D. So now path difference S2 is more, S1 is less. S2P minus S1P. Delta X is path difference. Delta X is path difference. S2P minus S1P. So now S1P square, S2P square. S2P square is equals to. S2P square is equals to. This is also D, this is B. B square plus D square. S2P square is equals to B square plus D square. S1P square is, S1P whole square is, S1P whole square is D square. So now S2P minus S1P. S2P minus S1P. S2P value root over B square plus D square. S1P value D. So S2P minus S1P. S2P minus S1P. B square plus D square whole to the power of 1 by 2 minus D. S1P is D. So now here we have to take B square is common. 1 plus D square by B square whole to the power of 1 by 2 minus D. So this is B 1 plus D square by B square whole power 1 by 2 minus D. So B plus, so according to binomial approximation, 1 plus x whole power n, 1 plus nx, 1 plus D square by 2B square minus D. Minus D. So B into 1. This is B into 1. Next one is B into D square by 2B square minus D. So now here we have to calculate 1B cancel. 1B cancel. So here distance between two slits. So separation between two slits is B. So and the screen is a distance B, D. So S2P minus S1P. S1P is D. So B square minus D square. If you take common, what happened? D square by 2B. D square by 2B. D square by B. B plus minus D. If you take D as common here, D square is common here. Then S2P minus S1P is equals to the missing wavelengths 2n minus 1 into lambda by 2 is equals to B square by 2B. B square by 2B. So here 2n minus 1. 2n minus 1 lambda by 2. We need to calculate lambda by 2. Lambda cancel. 2n minus lambda is equals to D square by B. So lambda is equals to D square by 2n minus 1. N value 1. So lambda is equals to D square by B. D square by B. Missing wavelengths are D square by B, D square by 3B, D square by 5B, like that. So now for RMS value for an alternating current, RMS value may be equal to peak value. For AC, RMS value may be equals to peak value. IRMS is equals to I peak value. So average value, I average or V average may be equals to peak value, VM or VP. So now here RMS value may be equals to average value. RMS value may be equals to average value. So all of the generally in RMS current may be equals to peak value is possible. RMS value equals to peak value. IRMS or VRMS is equals to VP or VM. So I average or V average is equals to V maximum or I maximum. IMS or may be equals to V average or I average, like that. So VRMS equals to V average or IRMS is equals to I average. So mathematically it is possible. So among the following option all are correct. Next 66 the question. So direct current of 5 ampere, IDC is equals to 5 ampere. Supposed on alternating current I is equals to 10 sin omega t through the wire. Effective value of resultant current. So I is equals to IDC plus IAC. This is 5 plus 10 sin omega t. This is I. We need to calculate the effective value of resultant current. Effective value of resultant current means RMS value. So generally IRMS square is equals to 0 to t I square dt by 0 to dt. So I is equals to A plus B sin omega t. So IRMS is equals to root over A square plus B square by 2. Like that. So I is equals to IRMS is equals to, from this question, 5 square plus 10 square by 2. So 5 square is 25, 10 square is 100 by 2, 50. So root 75. So IRMS is root 75. Root 75 is 5 root 3 ampere. IRMS is 5 root 3 ampere. Next question number 67. The potential barrier V volts. Potential barrier or voltage barrier or potential barrier is V volts. So in a PN junction, the thickness of the depletion region is D. An electron with a velocity V approaches PN junction from n side. The value of velocity of electron crossing the junction. The value of velocity crossing the junction they are asking. Value of velocity crossing the junction. U they are asking. So velocity is moving. So here charged particle is moving. Work done by the force is equals to change in its kinetic energy. Work done by the force. Here what type of work is done here? So work done is EV. Change in kinetic energy is half mv square minus half mu square. So now, EV is equals to half m is common, v square minus u square. So 2ev by m is equals to v square minus u square. U square is equals to v square minus 2ev by m. So u is equals to root over v square minus 2e by m. So this is the velocity. This is the velocity of the charged particle. So moving from n side. Now the number of turns of primary and secondary